What do you think that that student used for material to make the model solar system? Luca?
Honey.
Well, honey would be very, very sticky, but that also wouldn't be able to come together. Beth?
Peanut butter?
Yeah.
Ooh, man, I'm gonna try it with peanut butter. What do you think, Lila? Oh, sorry, Lila, I tried to unmute.
Gum.
Say again?
Gum.
Gum. Oh my God, that would be crazy. I love it. Hannah, what do you think? Louder, please.
Cookie dough?
Oh man, I have to tell you, if you freeze cookie dough, there is no better material in the world. The only problem is I would eat half the solar system. Alex?
Maybe like slime or something.
Good, that's a little too slimy. He used
Imagine getting enough cookie dough to make the sun.
Oh.
huge marshmallows, okay?
Wait,
And his hands got so sticky, he couldn't even touch the buttons on the computer. Oh my God, yuck, yuck, yuck. So anyway, this can be really yucky or it can be a lot of fun. Now, here's the question I have for you.
I'm gonna help you out.
I have the same kind of
Is
marshmallows.
the relative size of Earth
It's me.
to the moon? Oh, by the way, whoever has violin in the background, you'll have to mute yourselves. If you have something like that going on, you have to mute yourself, because then we have to hear all that background noise. Now, this is a mound of Play-Doh. What portion of this do you believe will be the volume of the moon? This is our planet Earth. Oh, and by the way, what is the name of our moon? Does anybody know? Please raise your hand electronically if you know.
Moon.
I'm looking for them. I have Ethan.
The moon.
No.
The moon. That is that like saying, hey, what's your teacher's name? Teacher. Alex, what do you think it is?
It has no name. It's the only one with no name. There's like Phobos, Deimos.
Wait a minute. Ethan M., what do you think?
There's no name.
Yeah, guys, it's a little ironic that we have the only moon that has not been named. I would like to name it with you guys at some point because I plan to go there someday. All right? Now, what I want you guys to do is this. Send me a chat right now with the volume ratio of what you think is the Earth to the moon. If you know the answer because you've looked it up, don't send a chat. I'm interested more in what your conjectures are looking at the moon every day of your life in the night sky.
Oh,
Have you thought about the relative size of the planet you're on? So send me a chat. I should have like 1,000 chats. I already got Will, I got Hannah, I got Seth. Remember, this is volume. We're not talking about the diameter. We're not talking about linear. We're talking about three-dimensional ratio. All right.
wait. Wait. I didn't type anything.
Good. This is good.
Is it moon to Earth or Earth to moon?
It is Earth to moon. Earth to moon. Now,
Okay.
while you're doing this, I am going to share a picture of the actual size in scale of the moon and the Earth. And I not only did I do that, but I wanted you guys to see that the diameter of the moon, 1, 2, 3, and about a half. So that's the linear. Now I want you guys to look at this. Pick up your Play-Doh, please. And you should see my mound right here. And by the way, why don't you guys smush it flat? Smush it flat and form it into a rectangular prism, please. Form it into a rectangular prism, which means that instead of a rounded edges like a cylinder, it's every single face is a rectangle. And what I want you to do, once you get it into a uniformity that you like, I still don't like mine, so I'm going to work it. Now I kind of like it. Nice and right angular. I want you to please cut off 1/50th. And you can use any algorithm that you wish to cut 1/50th. You can literally cut 50 pieces, or you can think of a creative way to think of how you would do your 50th. Now, for instance, I got an idea last week from Adalia. When we were cutting into tenths, if you remember, Adalia first cut half, which I really kind of liked that cut. I really liked that cut. I'm looking for my knife, and of course it's right in front of me. So I'm gonna go for 1/2, and then I'm gonna go, but I'm gonna be quiet now and let you guys think of how you would do it. And then I'll share my idea with you. And please raise your hand electronically if you would like to share your methodology with the group. And I don't even care if it's the same as someone else. You can just give me like one of those little, hey, I got it too. I'd love to hear how you did yours. Okay, we're going to start with Ethan M. Can you give us your methodology, please, of cutting off 1/50?
Oh, my method would be to, I haven't done it yet, but to cut I would just make marks to make it 10 tenths, and then so I would make a mark. I would cut it into tenths, and then I take one of those tenths, and then I cut it into 5 pieces, and I take one of those 5 pieces.
I really like that. So basically what you did is you did, remember what Adalia helped me figure out is how to really cut a good set of tenths. And then I took 1/5 of my tenth. And do you guys agree that 1/5 times 1/10 is 1/50th? Do you guys agree with that? Yes or no?
Yes.
Yeah.
Okay.
Yeah.
Did anybody else, Zarak, did you have a different methodology?
No, same.
Same thing?
Yeah.
Okay, now guys, how many 50ths is this larger mound right now? Go ahead, Luca.
49 50ths.
So this guy is 49 50ths. This little guy is 1/50th. Every night, you guys look up at this. you look up at a massive sphere, and there are many theories about this. I have done a little bit of research. This is not a theory of mine. I've done a little bit of research about the formation of the moon, and a lot of people think that there was a massive sort of explosion about 95 million years after the formation of our solar system. And this is when the Earth was still molten hot. And by the way, make your Earth while we're talking. And when that explosion happened, it created this massive moon. And when I say massive, it is 2,700 miles across diameter-wise. Alex, what are you going to share with us?
I'm pretty sure it's like what I was talking about last week too, like it's the collision impact theory. So I'm pretty sure, yeah, it was 13 billion years ago, which was basically since the Earth formed 13 billion years ago.
The solar system, they say, formed
14.
a little more than 4 billion years ago. So
14 billion was the universe.
4.6 billion years.
3.5 billion years old is how old the Earth is. And then while it was still molten, a Mars-sized rock came and hit it while it was still molten, which took off a chunk, which is known as the collision impact theory. And because Earth at that time, and it still does, had an atmosphere and a gravitational force strong enough for that mass or the volume, it was able to catch the moon in its orbit. And because it was molten, both of them were molten, they were able to, and because the moon had its own gravitational force, instead of just being its own oblong shaped object like Phobos and Deimos, it had its own gravitational force, which packed both of them together into their own spheres again.
Beautiful, beautiful theory. Again, nope, none of us were there. None of us know for sure.
Yeah.
But
it's the most popular at the moment.
It's a pretty good theory. Now, I want you guys to look at this. Remember, and I think Hannah, you were right on when you said it was 50-1. And now, technically, what is the technical ratio, guys? Go for it. Come on, the technical ratio is not 50-1.
50 to the third to 1.
No, 2%.
The technical ratio is
49-1.
the technical volume ratio is 49-1. Now, we're going to use 50-1 today, okay, to talk about it. But I want to understand this a little bit better. So first of all, what I want you to do is put your moon and your Earth aside. I'm going to share once again my computer screen where, guys, we figured out just now that the relative volume scale of the Earth to the moon, and we're going to use the number 50. You know that the number is probably closer to 49, but let's use the number 50 because it's easy to work with. Now, if you take the diameter, do you guys have calculators with you today?
Yeah.
Yeah, please only use them when I ask you, because I want you thinking about a lot of things today. We're going to do without a calc. But right now, I want you to take the actual diameter of the Earth, which is 7917 miles, not 8,000, although I always say 8,000. And I want you to divide it by 2,158. And don't say the number out loud, but that is the number of the diameter ratio. So the diameter ratio, that's a linear. Anybody want to give it to me now? Go for it.
3.66867 4699.
And really, we never generally go out more than a few digits, but Luca, you're right. Why don't you guys just do 3.668? Now, I want you to try a little something for me. If you know how to cube each number, go ahead and do that. So cube 3.668, which is 3.668 times itself 3 times, and then cube the number 1. And don't say it out loud, but I want you to marvel at how beautiful the number gets to be. And anybody want to share that? Don't say it out loud just yet. I'm looking for more people to participate. I'm going to hit unmute all, asking everybody to unmute themselves. So please do that. And all right. So only one, guys, is it true that only one person here has been able to cube the number 3.668?
I got it.
Well, who's the I got it? Luca? And how about Hannah A? What did you get, Hannah A?
I'm not sure quite yet.
Okay, and what about you, Regan?
Oh my.
And Kathy, what about you?
I got it.
I'm not sure yet.
Okay, so guys, I'm gonna write this out for you.
I got it.
You're doing 3.668 to the 3rd power, which is the number times itself 3 times. The other way to key it into your calculator, if you have an exponent button, which usually looks like an up arrow, is put a 3 for a cube. Okay, Andreas, can you give me the number?
It's around 49.35.
And guys, how sweet is that volume ratio? Pretty cool, right? Now, what I really want you guys to focus on is this. Look at this picture. The relative volume scale of the moon to Pluto. If Earth to Pluto is 1,000 to 1, then the moon to Pluto is what? Seth, do you have that?
No.
Okay, I thought you had your hand up. Luca, what do you have?
That was for the other one. That
Oh,
was
sorry
for
about that.
3668 cube.
And
200.
Ethan M., raise your hand electronically, please. And Alex, go for it.
Because the Earth is 50 to 1 to the moon, which means the Earth is 50 times greater, so 1,000 times 50 would be 20. So
And
it's
therefore,
21.
1,000
And-
divided by 50 is what, everybody?
20 to 1.
It is 20. So the moon to Pluto, guys, the moon is 20 times bigger than a planet. That's pretty amazing. Now, I do have a theory that I was talking to today with my best friend. Okay, my best friend and I have known each other for 42, maybe 43 years. And I didn't think about this until just today. I was talking to him about what I learned about the ratio of the Earth to the moon. And I told him that I started dividing diameters of planets by their diameters of moons. And guess what? Our number 3.668 is essentially the smallest number, which means that the moon is the largest relative to its planet. The next one that's not even close, Neptune and Triton, I believe it is. Neptune is 18 times wider than Triton. 18. Now here's my theory. Because the moon is so large in comparison to our planet, the gravitational pull is so strong, giving us rising what?
Tides.
Rising tides and lowering tides.
And it
It
causes
gives us
seasons.
the seasons. It creates weather. Guys, I think that that gravitational pull is the answer to life. Now, I could be completely wrong, and I would love for somebody to prove me wrong, but
No,
right
that is-
now, that's a conjecture, and you bet that I'm going to spend some time studying that.
It is
anything you have
true.
to add?
It is a true fact.
Well, I'm not
I've
sure it's
re-
a fact.
I researched it this year. It's because the gravitational pull and the angle, I'm pretty sure it's like the atmosphere, and the gravitational pull towards it causes wind, which causes tides.
Well, it'll be very interesting to do the research. Now,
Pretty sure there's a crash course on it.
now hold on a second, Alex. We have a lot to cover. Now, I want you guys to definitely do the research and see if Alex is right, if my conjecture is right. And here's what I want you to do now. Do you guys see this green line?
Yeah.
That's the distance between the Earth and the moon. But that looks to be about 3,000 miles. In fact, from East Africa to West Africa is 4,600 miles. So is the distance between the moon and the Earth 3,000 miles? And if you know it, the answer, don't say it just yet, but I want you to think of it. Remember how everything we've seen in the past are pictures that are essentially lies, so we can fit stuff in our pictures? There should never be a picture. If this picture says relative volume scale, which is true, it should also have an asterisk that says completely inaccurate in terms of relative distance. Now, guys, go back to your moon and your Earth. You would need 30 of these. The distance of our diameter, about 8,000 miles, 30 of those. Everybody do the math right now on paper. 8,000 times 30. That is the actual distance.
240,000.
Please do not say it out loud. Alex, if you do that, anyone who has not completed it stops working. So it's really important that you not call out the answer. Everybody's working on that.
Sorry, I thought I was muted.
No, that's okay. It was my fault. Now watch this, guys. I want you guys to say the number out loud on 3. 1, 2, 3, go.
240,000.
And guys, 240,000 miles is correct. And I wanted you guys to see a picture of 30 Earth diameters next to each other. I mean, guys, this is actually 30 of them. And that's how far the Earth is from the moon. Now, take your Earth, please, and can you guys measure its diameter right now? If you're really lucky, like me, it'll be 8 centimeters. Why do I consider 8 centimeters a lucky diameter? It's because the Earth is approximately 8,000 miles diameter. Therefore, 1 centimeter represents 1,000 miles. Therefore, how many centimeters apart is the Earth and the moon at this scale? Flag in, please. Raise your hand electronically. David, what do you think?
What?
I'm sorry, maybe Cedric, what do you think? How many, if 1 centimeter is 1,000 miles and I've got 240,000 miles, how many centimeters apart would these have to be? Cedric, you know it?
240.
2,400.
If you say it again, How
Oh,
about you, Will? Adalia?
240,000.
Not 240,000 centimeters because 1 mile, I'm sorry, 1,000 miles is 1 centimeter. Seth?
240 centimeters.
Okay, guys, I want you to place these 240 centimeters apart. Now, in order for you to do that, I don't know if you have a handy metric stick. This is 1 meter, which is 100. You would have to put it 2 of these plus 40 more centimeters. If your moon and Earth are that far apart, that's the actual distance, relative distance to the size of your Earth and Moon. Pretty amazing. Why don't you guys try to do that right now? Like stand up and go back. Like for instance, I'm gonna measure out. I'm gonna measure out 1 meter to here, and then another meter. You know what? I like it. I got to a good place with 240 centimeters away. And I really feel like when I look at my Earth and I look back at my moon, that's what I'm looking at. Now, a lot of people think they understand the answer to the next question. Zaraf, do you have a question for me? And Alex, do you have a question? Luca, do you have a question? Okay, try to unmute yourself, boys, so you can share.
I didn't have a question. I just raising my hand for the last question.
Okay, no problem. Now, what I want you guys to do is this. I want you to tell me, do you have the mathematics? Oh, by the way, before we go ahead, I want you guys to look at this crazy picture that I made. I made a picture of this little green dot here. That little green dot to scale to the Earth is 254 miles above the altitude of Earth. That is how high the International Space Station is in altitude in orbit. Now, doesn't it look like it's practically sitting on Earth right now?
Yeah.
Well, guess what? Look at the other green dot. This green dot, which is 8,000 plus 4,000, that's 12,000 miles. That's the altitude of GPS satellites that we learned about a few weeks ago in Mathletes. So guys, there is almost nothing between the Earth and the Moon after the satellites, the outer satellites. Guys, there's a lot of space.
What's the highest satellite?
You know, I do not know. All I do know is the reason why 12,000 is used, because that's the right mixture of distance to coverage of the Earth. And I think that there's 24 satellites, 21 to 24 satellites that cover the Earth at all times. Now, follow with me the next picture. The next picture shows the volume ratio of the sun to the Earth at 1.3 million to 1. The volume ratio from the Earth to the Moon is 50 to 1. I want you guys to work out right now the volume ratio of the sun to the moon. How many moons could fit inside the sun? And I want you to all write it down. Send me a chat. And I'm also really interested, and do not use a calculator for this, please. I am really interested in how you think about this. So you have 1.3 million. Then you have to do something with 50. I don't want to give away the operation right now, but I am looking for Alex, I agree. And guys, is it addition, subtraction, multiplication, or division? Go.
Multiplication.
Multiplication.
And do not do anything with the zeros. What is 13 times 5, everybody?
65.
And how many zeros do I tack on to the end?
6.
If you said 6, you know that the sun is 65 million times bigger than the moon.
Bet we're doing Pluto now.
I'm sorry, no, we're not doing Pluto now. We are doing the moon. So since the Earth to the moon is 50 to 1, since the sun to the Earth is 1.3 million to 1, we multiply them and we get the sun to the moon. Everybody have that?
Yep.
Okay, now, I want you guys to tell me, what is the diameter ratio from the sun to the moon?
What is the diameter of the sun?
I'm not going to tell you, but I will tell you this. We are going to use an estimate of 64 million to do this calculation. And the reason is I want you guys to take the cube root. Don't say it out loud. I want you guys to take the cube root of both 64 and then the cube root of 1 million and multiply them. Take some time to think about that. And that's going to be your linear ratio. The linear ratio is always the cube root of the volume ratio. The volume ratio is always the cube of the linear ratio. So what number times itself 3 times is 64? Go.
4.
Say it out loud now.
4.
And what is, whoever's got the barking dog, please hit mute. What is the cube root of 1 million? The number times itself 3 times, not 3 times the number, but the number times itself 3 times. On 3, 1, 2, 3, go.
1,000?
Not 1,000.
100.
Just for something here, whoever said 1,000, watch this. 1,000 cubed is a 1 with 9 zeros. So that is a billion. Got that? But let's go back. And what is 4 times 100, everybody?
400.
400.
And guess what? That is the diameter ratio. The sun is 400 times wider than the diameter of the moon. Why is it then that the sun looks to be exactly the same size? Who's got some theories? I've got some hands up, but I want to hear from people I haven't heard from in a little bit. Regan, we'll start with you. But you other guys leave their hands up. And Walker, also put your hand up electronically. Go for it, Regan.
Is it because we're closer to the moon?
It is because of that. Now build on that, Walker.
We're closer to the moon and farther away from the sun.
We are closer to the moon. That is true. I want you to build on it if you can. I'm going to choose Hannah. Go for it. Hannah, are you muted? Oh, you're still muted, honey. You've got to unmute yourself. Everybody unmute yourself right now, please. Okay. While you're working on the unmute, I am going to call on Neil. Nick, sorry. Nick, next time name yourself other than your last name. It'll help me remember that. So go for it, buddy.
Because like someone else said,
we're closer to the moon and than the sun, and because we're closer to the moon than the sun, the moon's closer to us, so like we see it like it's like closer to us. So
It is closer, but I need more details. Seth, what do you think?
Because the moon is so close up, you see it bigger because that's how it works.
I love it. I love it.
And since the sun is, and like that's why the scale looked so bad in like last week's with like the sun and all the other planets.
Yeah, Adalia, what do you think? Hold on one second,
So
Seth.
that's why the sun is so far away and it's so big.
Yes, I want to hear from 2 more people here. Adalia?
Since the sun is farther away than the moon, it looks like the sun is smaller.
That is true. Alex?
It's kind of like eclipses. Due to the fact that the moon is orbiting us, it's only eclipses where you can see the true value scale, because they're both at their own orbit. The orbits don't always line up, but when they do, you can see when you see partial coverage. But because you can't see coverage it's kind of in 2 different places. So your eye mainly like registers the one, and the moon you can like notice like if it's sunset, because it's farther, it's like harder to like see movement. But the moon you see like more movement because less movement because it's closer, so it's bigger, and that's why it moves less because you can see slow. But because
if it's
so far away and orbiting,
those things are all correct, but that's not the specifics as to why we see it as the same size. I'm going to go with Zarak and Luca, and then Walker. Go. Zarak, you'll have to unmute yourself, please.
Yeah.
Keep yourself unmuted.
So it's like because of the depth perception that you see.
yeah.
It is depth perception, but no, it is actual perception. Luca? Luca, keep yourself unmuted, please.
If you look from high up, you'll like high up in a tree, and then there's a portion on the ground directly under you, and then there's another portion next to you. The portion on the ground, you'll see it bigger, and you'll see it smaller because you're further away, and it's your perception that it looks different. It's not like that. It's a different size.
That's right. That's right. Walker, what's the last
Since
comment?
the moon is closer, then it kind of covers up more of your perspective when it's like closer to the.
All right.
Like
guys.
say you have a flashlight.
Yeah.
And you put your hand like right near it, and it covers up all the light. But if you put it farther away from it, it only covers up some of the light.
Now, guys, are you ready for the answer? Because the diameter of the sun is 400 times bigger. And guess what?
Is the moon 400 times closer?
Yes. The distance of the sun to the moon from Earth. And by the way, I took a little liberty and used 96 million only because I wanted the numbers to be easy. But look, guys, if I divide the top and bottom by 10,000, and then I have 9,600 divided by 24. Can you divide the top by 3 and the bottom by 3 on 3? 1, 2, 3, go.
24 over 1.
No? 30. Come on, guys. By 3. By 3.
3,200
32 over 8,
over 8.
which is 1,600 over 4. Help me out with the next one.
400 over
400.
Which is what, guys?
400 over 1.
So guess what? Because the sun's diameter is almost exactly 400 times larger than the moon's, and the sun is exactly 400 times farther from Earth than the moon, they look identical. It's not depth perception. It's not anything but the physics. And the solar eclipse, guys, that you are not going to see in the next 11 days, like in 11 days from now, on summer solstice, there's going to be a solar eclipse. And I say you are not going to see it. And the reason is you don't live in Africa, Europe, or Asia. By the way, if you did, you might have a chance to see it. I wouldn't go there though, just to see it, because you may find that there's cloud cover. But guys, look at the moon here. Do you see the picture? This is what you see. And then you see the same exact ball of fire. So the next time you look up in the sky, just realize that this guy is 400 times smaller, but this guy is 400 times farther away. Now, I want you all to rip off the back page of your packet. Rip off pages 15 and 16. And I'm going to change the screen now. And I'm going to show you, let's see. We're going to do a new share. Okay. Now, you should see my overhead cam. And what I want you guys to do is I want you to please fold it hot dog. Please fold it hot dog. And let's see what we have here. You ready? My very educated mother just served us 9 pizzas. Do you guys agree with that? Right? Sun to Pluto. Now, what I want you to do is I want you to put a little P at the end here. And I want you to put a little S at the beginning. Don't worry about the squares. Now, the S represents the sun. P represents Pluto. And this picture, oh, actually, I'm going to do it again over here. Sun and Pluto. This picture represents what we think. How are the planets distributed in the solar system? And I'm going to do what I've always been told. Mercury, Venus. You guys do this right now. Whatever you think. You don't have to follow me. And you should only do this if you have not looked ahead in the material, which you should not do. So, and by the way, does anybody see an interesting word in there?
Yeah.
What do you see? Nick, what do you see?
Sun.
I see a sun also. Now guys, we're going to come back to this in just a minute. I want you now to do the same thing. Please turn it over. Same thing, Sun and Pluto. And then I want you to write the word reality. Okay? I would much rather live in a world of reality. So therefore, I am no longer going to use that estimated 96 million miles. We know, guys, that the distance from the sun to Earth is approximately what, guys? Come on, help me out.
93.
96 million miles.
And it is 93 million miles, which is, by the way, it has a special name. It's called an AU. So AU, oh, by the way, whoever's got that their computer makes a noise every few seconds, you've got to turn that off, please. It's really important because we all hear it. Okay, please turn that off. Now, AU stands for astronomical unit. We measure distances not by centimeters, not by meters, not by kilometers. We measure distance by AUs when it comes to planetary distances. When we talk about different solar systems and galaxies, who knows what measure we use then? Please don't say it out loud. Raise your hand if you know the measurement. Hannah A., do you know what we used? Hannah A., no. Lila, any idea what measurement we use? Kathy, any idea? William?
I have an idea.
Go for it, William.
Miles.
Louder, please.
Miles.
Ah, not miles, because this is in miles. AU is in miles, but then we replaced that. But that was a great choice. Ethan G.
Light years.
And the answer is light years. So in our own solar system, we do not use that. I want you guys to put by Pluto 40 AUs. Pluto is 40 times farther from the sun than is the Earth. 40 times. Now make a little dot in the middle. Now, a lot of you will want to be accurate. You could always fold the paper, and wherever the crease is, that's going to be your middle. That middle planet, guys, is Uranus. Now, everybody write down the number of AUs. If the sun is here and Pluto is 40 and Uranus is exactly halfway, write down the number of AUs and say it on 3. 1, 2, 3, go.
20.
It must be 20 AUs. Now I want you to go halfway between Pluto and Uranus, and you know that that has to be what, Olivia?
Poseidon.
Olivia, what does that have to be? Can you unmute yourself so you can be heard?
Poseidon.
Everybody unmute themselves.
Poseidon.
Really important. Please do not keep yelling out a name. I'm going to call on people that raise their hand. Zarak.
10 light years.
Yeah, not 10 light years, but I want to know what planet it is first.
Oh, what planet?
Yes,
Neptune.
Neptune. And William, how many AUs?
30.
30 is correct. Now, go halfway from Uranus to the sun. And that is your ringed planet. That is Saturn. And Saturn is how many AUs? Frankie? Please keep yourself unmuted, everybody. I will just keep requesting that until you guys do it. Thank you. Frankie, what do you have?
Mr. Kramer, I have to mute myself because my sister's playing violin in the background.
I get it. I get it, my friend. No problem. Frankie, what do you have? If Uranus is 20 AUs away and the sun, what is Saturn? Come on. Halfway. Halfway.
10 AUs.
Louder, please.
10 AUs.
And 10 AUs is right. And guys, how many miles is that? Write it down. How many miles is Saturn from the moon?
9.
900 and what, guys?
930 million miles.
That's right. But it's nicer to say 10 AUs. Now, who can tell me halfway between the Saturn and the Sun is Jupiter? And Jupiter is 5 AUs. Now, I'm about to go for a thinner pen. I'm going to need a thinner pen because from Jupiter to the Sun, halfway, guys, that is not a planet. Write down AB is 2.5 AUs. Who knows what AB stands for? Say it out loud if you do, David.
Asteroid belt.
There you go, Seth, you got it. David, you got it. Excellent. And now everybody go half the distance. Half the distance from the asteroid belt to the Sun is the planet Mars. And that's about 1.25 AUs. Go half the distance from Mars to the Sun.
Wait, what? Earth.
That is not Earth. That is Venus. And Venus is about 0.6 AU. Now, halfway from Venus to the Sun.
Mercury.
And what's left, guys?
Earth, Mercury.
And that's Mercury at about 0.3 AU. Who can tell me? Please raise your hand electronically.
Because I don't have the material.
Somebody speaking to a parent, please mute yourself if you are. Can anyone please raise their hand and tell me, where is planet Earth? Where is planet Earth? Who can raise their hand electronically and give me the where is planet Earth? I got one person only. One person only. David, go for it.
It would be halfway between Venus and Mars, right? And that would be like 1 AU.
Guys, guess what? Earth is 1 AU. That, in fact, is how we come up with an AU. And guys, I want you to compare this picture to this picture. Isn't it insane that everybody thinks that the planets are equally spaced in the sky when the reality is nothing like it? Most of the planets, guys, are clustered within 100 million miles. And then Jupiter is about 500 million. Saturn is about 1 billion miles. Uranus is about 2 billion. Neptune, about 4 billion. Pluto, about 8 billion. And guys, 1 light year is about 6 trillion miles. It is mind-boggling to think of how small we are in this.
How many astronomical units is 1 light year?
Oh my God, that's a great question. Everybody do that question right now on their calculator. 6 trillion divided by 93 million. Don't say it out loud. 6 trillion.
Okay.
Divided by 93 million. Wow. That's a lot of AUs. By the way, that question was absolutely brilliant and lovely. And I'm just excited about that question. So thank you for asking it. I want to go back to, oh wait, it didn't work. Stop share, desktop, boom. There we go. Now, guys, what did you guys come up with? How many AUs is equal to 1 light year? How many AUs? Go. On 3. 1, 2, 3, go.
64,000.
Yeah,
Louder,
it's
please. Louder.
64.5.
516.129.
And we're going to say 64,516 AUs. Now, guys, remember, Pluto is 40. Pluto is 40 AUs. Now, this is the picture. When you take people through this exercise, have them, and here is the write-up of the exercise that I just did. Have them first fold the paper over, and you could even sort of sandbag them by showing them pictures of the solar system, where the planets always seem to be equally distanced from each other. Doesn't this feel like the planets are social distance, guys? They're all 6 feet from each other. Okay, I wonder if they think it's COVID-19. But for me, I know that the reality is very, very different. The reality looks nothing like what we think. So have some fun with that. Have some fun with that. The other thing is, and I gave you graph paper, 2 pieces of graph paper to work with that. I would love it if you also did all of the work on page 9, which is to simplify these division problems, to prove, in fact, that the relative size is 400 to 1, and the relative distance is 400 to 1. Diameter, sun to moon, distance in whatever, sun to moon. And there we are. Now we're going to do our cheer, and we're going to count from negative 40 AUs. Are you ready? Here we go.
By what? By ones?
Negative 40. Yeah, we're going to count by 1 mile.
How are you going to get to 0?
Watch this. Negative 40 AUs. Pluto. Negative 30 AUs. Neptune. Negative 20 AUs. Uranus. Negative 10 AUs.
Saturn.
Negative 5 AUs. Jupiter. Negative 2.5. Asteroid belt. Negative 1.25. Mars. Negative 0.6.7. Venus. Negative 0.3. Mercury. And Earth is 1. But what is the sun?
0.
0.
0 AU.
Negative 0.
0. 2, 4, 6, 8. Who do we appreciate? AUs. AUs. Go. AUs. Now, if anybody has any crazy ideas about leaving this planet, don't forget to invite me. I would love to come along as a passenger, and we're going to go for many, many AUs away. I can't wait. Walker, did you have a question? No, you're good?
No.
All right, guys, say goodbye to your friends. Have an awesome evening.
Thank you.
And
Bye.
think about these crazy questions. Bye, guys. Bye,
Thank
Steph. Bye, Alex. Bye, Hannah.
Bye.
Bye, Kathy. Bye, Regan. Bye, Brandon, Luca, Hannah,
Bye.
Ethan M. Bye.